Welcome back, Lightning Biologists. This is for the Monohybrid Problems, question number 4, 5, and hopefully 6 explained. So, question number 4, right here, we're going to be talking about guinea pigs. So, I always start with, we'll read the question. In guinea pigs, a black coat is dominant over white. Can two white-coated parents produce an offspring with a black coat? Why or why not? Now, this answer, hopefully for some of you, might come right to mind. You might be able to answer this immediately, and that's awesome because you're starting to see the patterns. However, I'm going to walk through it real quick. So if you get it and you want to jump ahead, you can go ahead and do that. But I'm going to start with my key again. We have me pushing the wrong button. So we have a black coat and we have a white coat, and black's dominant, so we'll give it a big B. And so the only way you're going to get a white coat is if you have a homozygous recessive. And so right here, it is saying that two white-coated parents. So you're going to cross a little b, crossed with a little b and a little b. The only allele both parent can give is the recessive allele. So when the question asks, can two white-coated parents produce an offspring with a black coat? No, absolutely no, they cannot. Why? Because there is no dominant allele in this cross. There's none to be given. And so there is no big B to be passed on to their offspring. And so every offspring, 100% of their offspring would be little b, 100%. And so all white, if you're crossing white guinea pigs, if you want a white baby, cross two white parents and you're going to be guaranteed that. All right, let's move on to question number 5. So question number 5. A brown mouse, so I'm going to go ahead and, shake that up a little bit. A brown mouse is going to be crossed with a heterozygous black mouse. So again, let's just go and we're going to start with our key. I have a brown and I have a heterozygous black. So the first thing you're going to be asking, those are your two phenotypes, but which one is dominant? And if you have, this is the word that's going to give it away right here. If you have a heterozygous black, hetero means that that's not the same allele. And so the black is going to be the dominant. And so black could be big B or big B, little b. This one's our heterozygous. And so the only way you can end up with a brown fur color in this in mice is if you have the two recessive alleles. And so our cross in this case is a brown mouse, so we know it has to be little b, is crossed with a heterozygous black. Heterozygous, hetero meaning it's not the same. And so it's big B, little b. If the female has a litter of 4, what are the chances all of them will be brown? Now there's a couple words in here that you really have to pick up on. The first thing that I really want you to pick up on is this right here. It says all of them. And there's 4, so all 4. Not just one, but all 4. And so keep that in mind as we're working through this problem. So let's go ahead and put the Punnett Square. So this parent right here is either going to give the big B or the little b. So I can set up my Punnett Square. This parent here we'll put on the side. It can only give a little b or little b. I'm going to fill in, bring the big B down with the little b across. Bring the little b down and the little b across. Bring the big B down and the little b across, and the little b down and the little b across. Those are our offspring. Those are our chances. So the question is asking if a female has a litter, which obviously it's the female having the litter, of 4. So there's 4 offspring. What are the chances that all 4 of them will be brown? So here's what you have to do. You're going to have, they have 4 offspring. So there's 1, 2, 3, 4. So here's what I want you to think about, because immediately you're going to look at this box and you're going to say, oh, well, 2 of the 4 are brown. But that's not what the question is asking. The probability is that, yes, 2 out of 4 will be brown. That's your chance, or 1/2, every time. However, the question is asking, if the female has a litter of 4, what are the chances that all of them will be brown? And so you go through, well, what are the chances that the first one will be brown? Because the first allele, the sperm and the egg provided for the offspring number 1 has no bearing on the sperm and the egg for offspring number 2. So offspring number 1, what are the chances that it will be brown? Well, I go back and I look, here's brown and here's brown. And so to be brown, there's going to be this 1/2 probability. My pen stopped working for a second, so I'm trying to get my pen working again. There we go. So brown is 1/2. And so for the first offspring, it's going to be 1/2. Okay? Parents produce sperm and eggs through meiosis. They reproduce. What's the chances that the second one will be brown? Well, just because the first one's brown doesn't take away the chances. If I flip a coin once and I land heads, it doesn't mean that the second time I flip the coin, I have any less chance of landing heads. So the second offspring also has a 1/2 chance of being brown. The third offspring has a 1/2 chance of being brown. And the fourth offspring has a 1/2 chance of being brown. And so now it's saying, what's the chance of all of them being brown? And when we say all of them, then we have to use the rule of multiplication. And so the first one times the second times the third times the fourth, which 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And so the chances that all 4 will be brown is 1 in 16 chance that all 4 will be brown. All right, that one was kind of tricky. I was getting good with math. Let's go on and look at number 6. So you guys are going to do 6 through 10. Please realize that you don't have to do every problem. These are more for your practice, kind of just get used to the problems. Oops. All right, so question number 6. Question number 6 reads, so right here reads, in cattle, black coat is dominant to white. So again, I'm going to start with my key because I always do. Black is dominant, white is recessive, so it has to be little b, little b. A farmer has a black male. All right, so black male. Ooh, I don't know if it's heterozygous or homozygous, do I? It's an undetermined genotype. How can the farmer determine the genotype of the male? Well, we're talking about cattle, and we're talking about males, and we want the male to be able for breeding purposes. And so one of the ways that you can determine if the black male, what its genotype is, and you guys, some of you are like, why does this matter? Well, this matters because if black hair color is a more desirable trait, then people are going to pay greater amount of money for a male that they know is homozygous dominant black, because they know that every offspring they get will be black. They can, if they know the genotype, then we can determine what the phenotype of the offspring would be in most cases. And so that's why this question's important. And really the only way you can figure this out is if you start crossing this male, and what would you want to cross it to? Well, if you cross it to another black female, then you don't know. But if you cross it to a white female, okay, So if you cross this black male to a white female, and every time you cross it, you get a black offspring in the F1 generation, if it's 100% of the time. So let's say you have 10 offspring and they're all black. Then you can say with pretty high probability that this male is a homozygous dominant. Because if the male, I'm going to change the color up here just to make my point. If this male happens to be heterozygous, now the F1 would be 50% would be black. And 50% would actually end up being white. And so if you bred this black male with this white female and you found that you were getting white offspring, then immediately you would know, hey, this male is a heterozygous. So how can the farmer determine the genotype of the male? It's going to want to breed the male to a white, little b female, to determine if 50% F1s are white. Then you're going to know that it would be heterozygous. I hope this helps you guys out. And I'll have another tutorial for questions 7, 8, 9, and 10.